I know about multidimensional arrays, but how can I use them? It's time to find out. Hello guys, welcome back to my YouTube channel. My name is Mike Mathuke E, and this is my Logic in Programming series. So today we're going to be looking at applications of multidimensional arrays, how you can use them in your code. I already did an introduction on what multidimensional arrays are. You can see it in the link up there. Well, so first of all, in the comments we got some questions about four-dimensional arrays and higher, mostly because most examples that we get start from 2D up to 3D arrays. You don't really find many examples of 4D arrays. So I'm just going to do a small sample of something that you can do with that before we start looking at how we can apply the 2D arrays majorly, right? So going here to my screen, there's something small I've prepared here. So let's imagine that we have three axes, right? Three-dimensional axis. So we have our x on the horizontal plane, we have our y on the vertical plane, and our z going into the horizon, right? So if I wanted to for example, draw a cube in this setup right here, it'll look something like this, right? So I have my cube highlighted in green, and then with I have my points here. So we have at this point we have, let me just highlight them with yellow. So when we come here, we'll have something like this, where we have 0, 0, 0 as our point. Of course, here we'll have this as our x, this as our y, and this as our z points, right? So you can see already we have a representation of a list here. So this is representing our vectors. We have another point here, of which will be 1, 0, 0. Why? Because x is at the position 1, while y and z are still remaining at 0. And then we have this position here at the top, where we have x at 0, y at 1, because we've gone one step up, and then z at 0 because we've not gone into the depth. And then of course we also have this, the other one, where we have x and y at 0 and then z at 1. I hope that makes sense. Just a little bit of a reminder of mathematics that you've been taught, and a bit of algebra as well. So in this point, if for example I wanted to represent, let's say, this point right here, I'll just change the color maybe to something purple so that we can see it differently. So if I wanted to represent this point here, for example, this would be 1 on x, right? Then 0 on y, because it's still on the first section of the y plane, and then we'll have 1 on z, right? If I wanted to represent this here, we'd have this would be 1, then 1, then 1, right? So I hope you can catch up with me on this. It's just a small reminder, so I'll just fill in for the rest. So in this case here we'd have, this will be 0, then 1, then 1, right there. And then I think the only point left is this, where this would be 1, then 0, right? So that's how you represent those points, right? So if I wanted, for example, to come and represent a face, right? Because we're trying to look at four-dimensional arrays. If I wanted to represent a face, maybe I can highlight each of the points that exist in this array, right? So let me highlight in a light blue so that you can see the face that we're trying to look at, right? So we want to see this first face that is looking directly at us, where the main points are where our main points here are these. We have 0, 0, 0, we have 0, 1, 0, we have 1, 0, 0, and you have 1, 1, 0, right? So if you were to try and represent this in an array, what it will look like is we have, so if you're trying to denote the face, so you have an array that contains the points. So we have, for example, 0, 0, 0. That's our first array. The second array we have 0, 1, 0, The third array we have 1, 1, 0, and the fourth array we have 1, just a second there, so 1, 0, and 0, right? So that becomes our full array. Let me just correct this so that it's completely covered, right? So this is an array that represents one face, right? So that represents the face that we've highlighted in blue. Already you can see that this is a two-dimensional array. So if I put those commas right there. So for example, if you wanted to represent all the faces of this cube, right? Basically you want to have all the data of the cube, then we'd have to add another array here, right? So I'll just move over a little bit. So we'd put a comma and add our second face right there, right? We'd add another face and so on and so forth. So this would also be enclosed in another array, right? You can see that. So now in this case, we'll have, this is our first array, the second array, and the third array. So we have a three-dimensional array that represents our cube, right? So that's one of the ways that you can use 3D arrays, right? Another way we can look at it when you're trying to do four-dimensional arrays. So now if you have done anything regarding game logic, like games usually use 3D mathematics, and in that 3D mathematics, what you usually have is, instead of quads, like for example here, you can see that what we have here highlighted in blue is a quad, right? A quad meaning it has four sides. However, in 3D programming, what you usually have is triangles and not quads, right? So to represent this in triangles, if you just draw a line that can show us a separation here, so this would be, if we split this way, we'd have this as our first triangle here, and then this, maybe let me highlight it in a different color, and then this will be our second triangle right there, split by this yellow line, right? So if I just go back so that we can view it differently, maybe I can use green so that we can see that distinct line there. So you have those two triangles. So if I wanted now to represent our face, remember we have to only represent faces in terms of triangles, right? So in this case, what we do here, we take the first triangle we have here is 0, 0, 0. Or let me use a black color. It's a bit easier to see. So 0, 0, 0. That's the first point, right? So you have an array there. Then the next point will be 0, 1, and 0. Then the next point will be 1, 1, and 0, right? So we've basically represented this triangle right here. And this we enclose in an array. That's our first face. But remember, we are also trying to represent the entire square, not just a small section of it. So if you wanted to represent the second section of the square, would have we'll take now 0, 0, 0, 1, 1, 0, and the last one will be 1, 0, 0. So notice I'm going kind of clockwise every time. So you have also this triangle that we've represented right here, right? So now, if you are to say this is the first face of the cube, then we would enclose this in an array saying this is our first face. Because when we are drawing it in the logic, when using your graphics pipeline, we'll represent the triangle. So we have this as our first triangle right here, and this as our second triangle, right? Let me just use this. So we have this as our first triangle and this as our second triangle, and both of them together make up the whole face that we have now here, right? This first face, the first quad that we have, right? Now that we have our first face, So when we want to represent now the entire cube, then we need to have an array of all these faces. So we'll enclose it again. Of course, this will become separated and all that. We'll have extra arrays. If I just move a little bit. So we have another array, comma here. Let me just put dot 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 to imagine that we add those extra arrays, so that now we have this will be a 4-dimensional array, right? So you can see that when you go 4 dimensions, basically what you're saying is the number of from the bigger array, when you're going down, will go down 4 times before we reach actual values of an array, right? So that's how 4-dimensional arrays will work. And if you want to go 5-dimensional arrays, it will also be trickling down the same way, right? We just have from the biggest array, we'll go into 5 times into the array. So in this case, for example, if this is our first array, then we go to the second one, then the third one, and then this is the fourth one, right? So that's how we are looking at it. So that's how 4-dimensional arrays work, and that's how other extra dimensions would work. It's just more arrays within an array, right? So I hope the person who asked that in the comments will be satisfied with this. In terms of application of this, there's a bit, it's not that direct, mostly because, for example, in this example, I used it as a 3D graphics, for example. But what you usually find is, instead of having this as an array of arrays, what we do is we create a class of these points that contains an X, Y, and Z position. So rather than just having an array, we have a class of points with X, Y, and Z. That's how we usually represent it. And then now we can abstract it even further. Now that we have points, we can have triangles, for example, represented in another class, right? Or a struct if you're using C++. So that we have a class that contains, if it's a triangle, then it contains 3 points, let's say A, point B, and point C, right? So something like that. So that's how you represent your triangle, you see. So that's in answer of how you represent it. In terms of application, mostly the approach is to abstract them into classes, and that's why you don't see these examples of highly dimensional arrays. However, today we are going to look at an example that is very applicable when using 2-dimensional arrays. That's what we'll focus on today. So I'll dive right into the code using C++ first of all, and then we'll complete this with Python. So what will happen here? We'll try to create an Excel sheet, right? So we have tabular data. Let's say, for example, you have scores of students in a school. So what you would need is maybe a header that says maths. Let's say there's math, there's English, for example. We just use a few columns, and then now we have the name of the student, and then now we'll have also the scores themselves, right? So let's look at this in code so that we can see how we can implement these 2-dimensional arrays. So if I switch to my C++ right here, so to represent this with code, I'll start with the headers. So the headers will have, first I'll hashtag include vector here, so that we have our dynamic arrays. Then we'll have an std vector of std string, right? It's just basically a dynamic array containing strings, right? And we'll give it the name headers. And then for the values, we'll just give, so the first header can be the name, the second header can be the, let's say math, for example, and the third header can be, let's say English, for example, right? So that's our first header, right? Then now we can have the second part where we have um, another array here, now representing the names. For this case, I'll just do two of them. So we have an std vector of std string, where we have names, and we'll present this with, let's just give an example of John, and let's say Jill, for example, right? Then now we need to represent now the scores. So we could represent the scores the same way that we represented the headers and the names, where we have individual arrays for each of those. However, we can go the route of two-dimensional arrays, since that's exactly what we are looking for. So we can do an array of integers. So let's do 2 by 2, right? 2 because we have two subjects and we have two people represented in this array. So first of all, I'll do it with the static version before we do it with the std vector, right? So here we can have, so just pick any random scores. Another one where we'll have let's say 120, for example. Right, so here we need to also give a name, which is scores, like so that we can represent it like that, right? So now we have our scores, and now we have all our data has been represented, right? So this 50 and 60 will be the math and English for John and Jill, and then our 100 and for John, right? And then the 100 and 200 will be the math and English score for Jill, who is our second student, right? So if I try to represent this now, if I want to write this out in a file, what I do is I first need to include fstream. So this is the library that will assist us to write it out to a file. And how it works is fstream offstream. Let's call it file, and then we'll give the name of the file. So this I'll write out into a CSV file, which, if you don't know, is just a comma separated file that allows us, now we can also view it in an Excel sheet. So let's call the file let's say tests.csv. So that's how we denote this CSV type. And then how we'll write out to the file is we'll just do this file, and then now we'll print out every single name that is here. So what we'll do, we'll print out the headers first for int I equals 0, I less than headers.size I plus plus, right? Then we write out into the file the headers at index I, and then we accompany that with a comma, right? So that's what it means by CSV. It's comma separated, right? Comma separated file. So that should be able to write out our headers, and then after that, what we do is we go to our new line, right? So if you don't know what CSV files are or how they work, just bear with me. We'll see the example as we go along. The next thing is now printing out the name and the scores, right? So what we do here, again, another loop, int I equals is 0, then I less than let's say names.size I plus plus. So that is our first identifier, and then what we'll do we'll write out the first name, right? And then add a comma. And then from here also, we'll also print out the values of this array, the actual scores that we have, so that we have, when you're arranging them now horizontally, we have the name, then we have the first score for math, and then the second score for English. So we'll have, we'll actually loop through the values of this first value, right? So so now we're looping through int j equals 0, then j less than, so in this case it scores at index 0, right? So remember, scores at index 0 is another array. So here we'd actually need to calculate the length. For now, I'll just put 2 since we're not using dynamic arrays. We're not using vectors, so it will be a bit tricky to do it directly. So I'll do an example with dynamic vectors, of course, afterwards. And then here we can now print out the values of scores at index I, then at index j, and also add our comma, right? Then now after we write this line, so this should cover that next row, and then the last line we'll write is file. We'll write now our new line so that we can go to the next section of our code, right? So this will be /n, like so. So this should be able to write for us a file in every line, and then file dot close, like so. Right, so we've opened our file and we've written it out and closed the file. So if I run this, we should be able to create a file in the same directory as your project. So if I go to that directory right here, you can see that we have this test.csv. If I try and open it, so I'm not using the normal Excel, you can see this is how it comes out, right? When you open it in Excel, if I try to open it as a normal text file, let me just edit with Notepad, for example, you can see this is exactly what you are trying to write out. You have your values, and then they are comma separated, right? So with each comma, you're saying I've completed this column, I'm going to a next one. So that's how it works, right? So of course the extra comma is not supposed to be there. It means we are creating a new column, but in this case it's not harmful to our code, right? So let's try and abstract this a little bit into something a bit more reusable, right? For now we just have static data. So if you were to do this into something reusable, I'll create a class and I'll call it a data frame, right? So this is now how we can apply it. So we can have public values. So we'll have our std vector of headers, right? Like so, which is a string. And then maybe we can create an std vector of names like we had before, and then the final section is now the scores, of which in this case I'll change it from what we had here to now a bit different. We can do it now with a vector as well. So if you wanted to do an array of vectors, what we would do is so it's std vector, right? Std vector of another std vector autocorrect is bothering a little bit. So we have an std vector that contains an std vector of integers. So that means we have a vector within a vector, right? And now that contains our scores, right? So maybe now our constructor will contain, so I can make this values private, and then our constructor can contain we'll have our data frame constructor where we pass in an std vector of std string, which has header values, and then std vector again for the name values, and then lastly we can have the same for scores, right? For score values. And then within this vector, what we'll do is we'll simply assign our values accordingly. So headers will be equal to header value, and then names will be equal to name values, and then scores will be equal to score values, right? And so when we come here, what we'll do is instead of doing all this, we'll just create a data frame. Let's call it df, and then we can give values. So the first thing we can give is the headers. So just copy what you have here. So the headers. The second one is the names, and the third one is our scores, which are like so, right? So now we've created an object that can be able to store all these values. And if you wanted now to print out this into a file, so we'd have another function, let's call it save to file, which will not return anything. So save to file. Let's say it will take in the name of the file that will give std string file name, right? And then what it will do is exactly what we have here. We'll just copy that, and all we'll need to change here is the file name, right? So since we're using the same names that we used here before, it should not be any trouble. So you should be able to save this to a file. So now you can see we've created a data frame, and then now you can store it into a file. So you can say df.save to file, and let's call it a different name. Let's say test data frame, so that you can see a different .csv. Right? So in this case, it will be very important to add the .csv so that it's able to be recognized. So if we run this, so it is completed running, and then when you go to our directory, we have this test data frame.csv. If we open it here, you can see we get the exact same result, right? Even if we open it with Notepad, you can see our result is exactly what we had before. And now in this case, when you've abstracted it like this, it becomes a bit more reusable. Of course, in this case, we have not put any restrictions or in terms of the size, because now the size of the headers should match as the same size of the name and the same size of score. Those are things you can implement as you go along, but this is a base of how you can represent tabular data like we have in an Excel sheet right in your code, right? So let's come and see how we can do the similar thing in Python, right? So in Python, we'll start off with a simple example, just the same way that we've done in C++. So we'll have an array of headers. So we'll have headers, which is a list of strings, and these headers will give the same as we had before. So we have our name, and then so we will give a column with names, a column with the scores for math, and a column with the scores for English, right? Just remember that this is Python and not C++, so this is how we represent it. Then we'd have the next one is now our names. We can represent our names, where we'll have a list of string, and then we'll represent this as, let's say we have Jack and we have Jill, right? So that would be our first column. And then for the next two columns, the scores of math, how we can represent them is we can have the scores represented as a list that contains another list of integers, which will represent our scores, right? So if I take this, what we can have is, let's say Jack scored 10 in math and 40 in English, right? And maybe Jill scored 50 in or 60 in math and maybe 5 in English. Oh, this is supposed to be like so, right? So that's just our two-dimensional array being used in that case. And then now if you wanted to print this to a file, what we'll do is we can do file equals open, and then we can give the name of the file. So we'll just use test.csv like so, and then to write to the file we'll just do file.write. So so here we'll have to pass our string, and then the last thing we'll need to do is close the file. So in this case, how we'll do it, we'll just append all these values into a string that follows the format that we're looking at. So I'll just create an output string here, and the first, for now it should just be empty. Then the first values that we'll give it is the values of the headers, right? So for header in headers, we'll give each of the values. So output, we'll add to the output the header plus now a comma. So what we're going to be essentially creating is a CSV file. That's a comma separated value file, right? So we'll have our headers. So the header will be name, comma, math, comma, English, like so. So those will be our headers. Next, we'll have the next values here, which it will be. So now we'll change it a little bit for I in a range of the length of names. What we'll do is we'll add to the output. Oh, just one more thing I forgot here. We need to once we've put the headers, we'll have to go to a new line, right? A new line like so. Then here, when you're continuing with the names, just separate this a little bit so that it's a bit easier to read. So when it comes to the names, we'll also do the same that we've done with the headers. We'll just give the name at index of I, so that it's dynamic. And then we'll add our comma. Sorry about that. We'll add our comma and a space, right? Then after this, remember on that row we'll have the name first, and then now we'll have the extra scores, right? So it will be Jack, for example, and then the score for math, and then the score for English. So you'll also have to do another loop here for J in a range of the length of names again, Um, this is just come from writing C++. So we'll add this scores, right? So we have the score at the index of I and then at the index of j, right? So here actually it will be better if we do it like this. The length of scores at I, right? So that we're actually getting the length of, so if we are looking at index 0 of I, we'll be getting the length of this array right here. So we'll do that and then add our commas, our comma and space as before. So that will print out every score for the first person. And then the last thing we'll have is a new line every time that we write. We'll have every time that we write that row, we'll have a new line, right? And then now in the end, what we have, our output here, is what we'll write to the file, right? So if I run this, just a second. So if I run this, okay, we have an issue here. Let me see. Okay, yeah. So here, scores at I and j. This is supposed to be string. It's a string. Since we are accessing an integer and we want to append to a string, we have to convert this into a string first. So this is what I've done right here. So that if we run, right, another thing I forgot here, this should have W notation. So basically you're saying we are opening this file in write mode, right? Otherwise the default mode is the read mode, of which if we don't have the file there, then it will fail, right? So if I run this again one last time, now it goes through, and if I try to look at the file that we've created, here's the test.csv. So you can see this is what we are aiming at. We have the name, the math, English, Jack 10, 40, Jill 60, and 5. Right, so if I try to open the file, I'll just go to its directory here. So this is the file. If I open it, you can see that this is how it looks like now in an Excel file, right? We have our name, Jack and Jill. So our name, Jack and Jill, math, 10, 60, English, 40, and 5. That's how we'd represent it now in our Excel file, right? So you can see that's how we can apply it in tabular data. So if I try and abstract this into a class so that it's a bit more reusable, what we can do here, let's say we create a class and let's call it a data frame, right? Let me call it my data frame. There might be a data frame already existing, right? So here we'll have exact same thing that we had before. The headers, so let me just do it within our constructor. So we have our init function, which will take in self. We have our header values, we have our name values, and we have our score values, right? And then in here, I'm expecting to have self.headers with the value that we pass in header value. We'll have self dot names here with the value that we'll have in name value, and then we'll have scores. So sorry, self dot scores with the value that we'll get from scoreval, right? And then in terms of type, of course, we have this here as a list of string. Let me just remove this. We have this as another list of string, and the last one is exactly what we had before, right? A list of integers. So now it makes this a bit more dynamic so that we can add a little bit more to it. And then if, for example, we wanted to write this out into our file, what you'd have is define a function that, let's say, save to file, and all it can take in is the name of the file, so you can pass in that, and then So we can copy this right here, like so that this is the logic that we'll use to fill in our values. So I'll just tab to make sure they're following, and don't forget we need a self right here, right? And then for the file name, this is what now we'll pass right here in the file.open. So here this will take header in self.headers. This will be self.names. Same for this, self.names. We have self.scores, and we have self.scores right there. So this should be able to print this out into a file. So now that we've abstracted this, I can comment this out, right? So that we work with our new data frame type. So what we can do here, we can create our data frame. So we can call it df, which is my data frame type, which we create by calling this constructor. So our header values, I'll just copy exactly what we had here. It's expecting a list of headers. The next thing, it is expecting a list of names, and the next thing it's expecting is our values now, right? Like so. And then what you can say is df.save to file. So now in terms of saving to file, we can just give a different name from what we had before. Let's say data frame .csv. Right, so remember the type is important there, and then we save. So if I run this, looks like we have an issue. Output is it's not associated with a value. Let me see. Right, okay, so here we are trying to append without actually creating the output variable first. So you can just have the output variable created first here, where you have the string, and then this is equals to an empty string, and then now you can start appending to it, right? So once you've done that, we can just run this again, and this time it's successful. So if I look at our file here, we have exactly what we had before, and if we try to open it here, like so, you can see it's represented in our tabular data, right? That is how we can utilize multidimensional arrays. So this sample that I've used is actually for those who use Python. There's a library that I know that is kind of popular when it comes to that tabular data called pandas. So this can give you a bit of an insight of how it works in the background, right? It's just an array of arrays that are working in the background so that we are able to access that data and represent it in an Excel sheet or a CSV file like we've done today. So that's usually how we can do it. I hope you have enjoyed this lesson. I hope you've learned something new. I hope you've also opened your mind in terms of how you can utilize multidimensional arrays, and I hope to see you next time. Cheers.